What's the difference between a herd of cows and a line for the ski lift? Eventually, the cows move. Hello everyone, today we will be discussing the physics behind skiing. First, let's watch a brief video regarding forces.
As you can see, the ball had force of gravity acting upon it, normal force of friction, and a force of drag acting upon it. And in this case, the force of gravity overpowered all of the other forces in the x direction. And a rock, for an example, the rock won't move because all the forces are balanced. Have you ever wondered about the real-life applications of Newton's laws of motions?
Newton's laws of motion? What are you talking about?
Let's recap Newton's laws of motion. The first law of motion states an object will remain at rest or at uniform velocity unless acted upon by an unbalanced force. The second law of motion states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Thirdly, Newton states there's an opposing force for every action equal in magnitude.
Nice.
Let's suppose the skier is on a horizontal surface. As we can see in the free body diagram, the skier is at rest because the normal force and the gravitational force are equivalent, and no other force is acting upon it.
Next up, let's assume the surface is horizontal. Let's say the skier skis are so smooth that there's no friction between them and the snow. Let's also assume that the skier is oiled up so that there's no drag on his body. If we give the skier a big push, he'll begin to accelerate and move at a constant velocity. Because there's no friction and no drag, there's no net force acting in the x direction, so he'll keep moving at that speed forever.
What about the second law?
Let's put the skier on a mountain. Here we can see in the x direction that the forces are imbalanced. The x component of gravity heavily outweighs the forces of drag and friction. As such, there's a net force pushing the skier to the right in the x direction.
What about the third and final law?
For the third law, we decided to find some real-life applications, so let's watch this video. Now let's explore the application of Newton's third law of motion outside. Let's run to the park and let's race. As we can see in this picture from the clip of me running, it is clear that I need to apply a backward force in order to move forward, which therefore proves Newton's third law of motion. To the park, let's check out the swings. In this clip, you can see that I push my feet into the ground one after the other. This causes the ground to push back with the same amount of force, causing me to move forward with the swings. Anyway, let's further discuss the application of Newton's third law in skiing.
In this situation, let's assume the skier wants to move forward and must apply force forward. To exert out forward force, the skier will have to exert a backwards force pushing back on the ground. This causes the ground to push him forward with the same amount of force. Having said that, this situation proves Newton's third law of motion.
Anyhow, now we will be discussing the importance of friction in skiing.
Friction is the force that opposes motion. Without friction, skiers would lose control of their skis. The loss of friction would impact the skier in multiple ways.
Friction always acts in the opposite direction of motion, indicating it decreases the speed of the ski. Typically, skiers use the sharpness of their board and its position to control their speed. However, without the force of friction acting upon it, the skier would lose total control of the board.
Additionally, the presence of friction between the edges of the ski and the snow helps the skiers grip the snow. Furthermore, this allows the skiers to carve turns and have control over the direction they're skiing in. Without the force of friction, skiers would lose the ability to change the direction of motion.
Lastly, the force of friction is essential for starting and stopping the skier. When starting from rest, the skier pushes himself to initialize motion and overcome the force of friction. On the other hand, when stopping, skiers use the force of friction to slow down through the use of ski poles and by changing the direction of the board to be perpendicular to the direction of motion. This increases the coefficient of friction.
To sum it all up, the force of friction is very important for skiing as it allows the skiers to control their speed, change the direction of motion, and both start and stop the board.
Skiing without friction could be very dangerous with potential risks of concussion, broken bones, and even worse, death. This is because without friction, the skier would not be able to stop their board.
Finally, the question arises, how does the force of friction influence the equipment used for skiing?
But my question is, what equipment is even used in the sport of skiing?
A skier requires a good set of ski boards and ski poles.
Taking into consideration how skiing is considered a hobby by many, it's important that skiing is both fun and safe. The base of the ski boards is typically made of polyethylene, a material with a coefficient of kinetic friction on snow of 0.02. Additionally, the ski boards are waxed from the bottom depending on the amount of snow. These two details hold lots of importance because they ensure the skis glide smoothly and quickly over the snow.
In terms of safety, skis tend to have sharp edges. This is significant because it allows skiers to grip the snow in carved turns, allowing them to change direction and even stop the ski very quickly. Nevertheless, skis tend to be large because they increase surface area contact between the snow and the board. This increases the friction on the board, hence providing stability and increased control.
In regards to ski poles, handles are usually made out of material such as rubber with a very high coefficient of friction, so the skier can hold onto the poles as easily as possible. Besides that, they're usually made out of lightweight and durable materials such as steel or carbide.
To sum it all up, all of Isaac Newton's laws of motion are present in the sport of skiing. In addition, friction is very important for skiing as it helps the skier control their speed, direction, lets them start, and allows them to stop. Finally, but most importantly, all of the skiing equipment such as ski poles and ski boards are constructed in ways that benefit from the presence of friction.
You know, trying to ski without friction would be like trying to teach a polar bear ballet. Slippery and bound to end in a tumble. Anyway, thank you for listening, everyone, and please feel free to ask us any questions.